In this video, we're going to be looking at exploring conic sections. If you find this video helpful, share, like, and subscribe. Exploring conic sections. A conic section is a curve formed by the intersection of a plane and a double cone. So by the intersection of this plane and the conic section, we can have a circle, an ellipse, a parabola, or a hyperbola. A circle is a curve formed by the intersection of a plane and a double cone such that the plane is perpendicular to the axis of the cone. General equation: x minus h squared plus y minus k squared is equal to r squared. hk is the center, so we have discussed this already earlier in our class. So let's write the equation of a circle whose center is at the origin. Okay, so center is 0, 0. Okay, 0, 0. So if we're going to put that in here, okay, then we can say that it's gonna be x minus h squared plus y minus k squared is equal to r squared. Now let's put our h and k in here. So that's gonna give you x minus 0 squared plus y minus 0 squared is equal to r squared. Now let's simplify these two. That's gonna only give you x squared plus y squared is equal to r squared. So this is now what you call your equation of a circle whose center is at the origin. An ellipse is a curve formed by the intersection of a plane and a double cone such that plane cuts the cone at one angle. So the general equation, here are the two general equations of the ellipse. X minus h squared over a squared plus y minus k squared over b squared is equal to 1 is going to give you the horizontal ellipse, while x minus h squared over b squared plus y minus k squared over a squared is equal to 1 is now going to give you your vertical ellipse. Now remember that the basis of horizontal and vertical is going to be where the a is going to be placed. So just like this one, in here your a squared is under x. It means that's going to be a horizontal ellipse. And in this case, on the second, the a squared is actually right under your y, so that's going to give you a hint that there's going to be a vertical ellipse in there. Okay, so problem number 2. Write the equation of a horizontal ellipse whose center is at the origin. Okay, so the center is at 0, 0 again. So, and it says it's a horizontal, so let's copy the horizontal formula in here. So that's gonna give you x minus 0 squared over a squared plus y minus k squared over b squared is equal to 1. Now let's simplify these two, and that's gonna give you only x squared over a squared plus y squared over b squared is equal to 1. So this is now our horizontal ellipse whose center is at the origin. Okay, is it also possible to create the vertical ellipse equation with the center 0, 0? Yes, we can do it. So if we're going to continue from this here, we can say that if the center is 0, 0, then we can say that this is gonna be x minus 0 squared over b squared plus y minus k, sorry, not k, it should be 0, 0 squared over a squared is equal to 1. So simplifying this one, this is now going to give you x squared over b squared plus y squared over a squared is equal to 1. So this is going to be the equation for our vertical ellipse. Okay, so let's look at the parabola. Parabola is a curve formed when the plane cuts at any one portion of the double cone of the angle. So general equations for horizontal parabola is going to be characterized by this equation where y minus k squared is equal to 4a times x minus h. That's going to be for our horizontal parabola, while your vertical parabola is characterized by x minus h squared is equal to 4a multiplied by y minus k. Now take note something in here that when you're dealing with horizontal parabola, it's the y variable that's being squared, while in vertical you're going to be looking at the x being squared in this case. Okay, problem number 3, write the equation of a vertical parabola whose center is at the origin. Okay, it's not actually center, we call it the vertex. Okay, this is the vertex. So the vertex is actually at the origin, which is 0, 0, and then it's a vertical parabola. So we're going to just substitute our h and k in this vertical parabola. So our x minus 0 square is equal to 4a y minus k. So this is going to be simplified as x squared is equal to 4ay. Okay, so this is now our vertical parabola equation. Okay, next is your hyperbola. A hyperbola is a curve formed when the plane is parallel to the axis of the double cone and cuts both cones. Okay, so our keyword in here is it's actually parallel to the axis of the double cone. Okay, so this is our key term when we're going to describe a hyperbola when it comes to its relationship with the double cone. Okay, so let's see general equations for our hyperbola. There will be two hyperbola equation that we'll be looking at. But the first one is your horizontal hyperbola, which is characterized by this equation: x minus h squared over a squared minus y minus k squared over b squared is equal to 1. While our vertical parabola is characterized by this equation: y minus k squared over a squared minus x minus h squared over b squared is equal to 1. So if we're going to create a horizontal hyperbola where the center is located at point of origin, then this is going to give us x minus 0 square all over a square minus y minus 0 square all over b square is equal to 1. Let's simplify everything. So this is gonna give you only x squared all over a squared minus y squared over b squared is equal to 1. So this is now the formula for our horizontal parabola with its center at point of origin. Conic's classification will help you determine which conic section you are working on. The general equation of a conic section is in the form of ax squared plus by plus cx plus dy plus e is equal to 0. So here are the key points that I would like you to remember when you're going to be looking at circle. Okay, you know that you are dealing with a circle when x and y are both squared and the coefficients on them are the same, including the sign. Okay, for example, let's look at this example in here. So let's take a look at 3x squared minus 12x plus 3y squared is equal to 2. So we can notice that the x and y are squared and they have the same coefficient. They both the coefficient are both positive 3. That info alone is all you need to recognize that you're working with a circle. Okay, the next one is parabola. How do we know that we are working with a parabola? When either x or y is squared, but not both. Okay, not both. So the equations y is equal to x squared minus 4 and x is equal to 2y squared minus 3y plus 10 are both parabolas. So in the first equation, you see that an x squared but no y squared. And in the second equation, you see a y squared but no x squared. Well, nothing else matters. Signs and coefficients change the physical appearance of the parabola, which way it opens or how wide it is, but don't change the fact that it's a parabola. A hyperbola, when x and y are both squared and exactly one of the coefficient is negative, and exactly one of the coefficient is positive. Okay, these are very interesting to note. The equation 4y squared minus 10y minus 3x is equal to 12 is an example of a hyperbola. This time, the coefficients x squared and y squared are different, but exactly one is negative and one is positive, which is a requirement for the equation of the graph of hyperbola. Okay. The ellipse. The ellipse, when x and y are both squared and the coefficients are positive but different. Okay, the x and the y both squared, coefficients are positive but different. So the equation 3x squared minus 9x plus 2y squared plus 10y minus 6 is equal to 0 is one example of an ellipse. The coefficient of x squared and y squared are different, but both are positive. Classifying conic sections. Classify each conic section. Okay, so number 1, x squared plus y squared is equal to 30. So both x and y are squared and the coefficients are the same, so this is going to give you a circle. Okay, let's go for number 2. Number 2 is x squared plus y squared is equal to 36. So we know that this is a circle. Let's go for number 3. Number 3 is x squared over 9 plus y squared over 16 is equal to 1. So this is an ellipse. Next number, x is equal to y squared. Okay, we know that very well. That's going to be a parabola. Number 5, x is equal to y plus 4 raised to 2 minus 2. So we know this is a parabola also. Okay, number 6, y squared over 25 minus x squared over 25 is equal to 1. So it's negative, 1 is negative and 1 is positive. That means this is going to be your hyperbola. Okay, next number. Y is equal to x minus 1 squared plus 3. So that's very obvious. It's going to be a parabola. Number 8, x minus 1 squared plus y squared over 25 is equal to 1. So we know that this is going to be an ellipse. Okay, so let's go to the next exercise. In the next exercise, classify each conic section and write its equation in standard form. Okay, so let's go for number 9. In number 9, only x squared, only the variable x is squared, but not both of them. So I can say that this is going to be a parabola. So the equation of the parabola is y equal to x minus 5 square minus 4. Okay, number 10. Let's look at number 10. Number 10, I can see only one variable is being squared in here. So this is going to give you a parabola again. So as for the equation is going to be, since the y squared is being squared in here, then we're going to have x is equal to 2y plus 5 square minus 1. Number 11. Okay, x squared plus 2x plus y minus 1 is equal to 0. Again, I can only see one variable being squared, so this is going to give you a parabola again. And as for its equation, the equation is going to give you y is equal to negative the quantity of x plus 1 square plus 2. Okay, number 12. So we're gonna go for number 12. Number 12, I can see that both x and y are squared. So this is going to give me a circle because the coefficients are the same. They are both 1. So this is going to give me a circle. Okay, the equation of the circle is going to be x plus 3 square plus y minus 1 square is equal to 1. Okay, next number 13. So in number 13, both are squared once again, but there's going to be a negative in here in between them. So this is going to be hyperbola. One is positive and one is negative. So the equation of hyperbola is x minus 1 square all over 9 minus y square all over 9 again is equal to 1. Okay, next number 14. Okay, in number 14, I can only see one variable being squared in here. So this is going to give us again a parabola. So the parabola is going to be y is equal to negative 3x plus 5 square minus 4. It's going to be on the y because the x squared is being squared. So this is going to be a vertical parabola. Okay, next number 15. Okay, I can see both variables are being squared. One is negative and one is positive. So this is going to give me a hyperbola. Okay, sorry, hyperbola. So one is negative, one is positive. So the equation is going to be y squared all over 9 minus x plus 4 square is equal to 1. Okay, number 16. In number 16, I can only see one being squared, and that's the y squared. So this is going to give me again a parabola. So this is going to give us the equation of x is equal to y minus 4 square plus 1. Okay, so pretty much that's all. So this is all for this lesson about exploring conic sections. If you find this video helpful, share, like, and subscribe. Thank you very much.